Jai Hind. Today we are going to discuss some numerical problems on the topics of sets and relation in the subject of discrete mathematics. So first one we are taking here is a set proof. We are given three sets A, B and C, and we have to show that A minus B minus C is equal to A minus C minus B minus C. So we'll try to understand here the method of proofs with help of definition, that is set builder form. Okay, so now let us try to understand how do we make these proofs. So as we know that when two sets are equal, then let me say x and y two sets, x and y two sets are equal if x is subset of y and y is subset of x. So we will use this property of sets to prove that the left hand side, that is A minus B minus C, is equal to A minus C minus B minus C. So what is given? The left hand side is given, let me take that as L. The left hand side is given as A minus B minus C. So what I am going to prove here is L is subset of R. So this part will do, and reverse can be easily done with reverse steps. What is reverse? R is subset of L. L is my left hand side expression and R is right hand side expression. Okay, so from these two we can say that L is equal to R. So I am taking here the first proof, that is L is subset of R. So to prove that, what I have to prove? L is subset of R. So I will take one element, any element from L, and I will show that it is present in R. So let me take an element x that belongs to L. So when x belongs to L, what does it mean? It means x belongs to this set. This is the left hand side. So what does it mean? X belongs to A minus B minus C. We are given three sets A, B, C. So when x belongs to L, it means x belongs to A minus B minus C. When x belongs to A minus B minus C, what does it mean? By the definition of difference, it means that x belongs to A minus B and x does not belong to C. This is definition of difference. We have taken two sets. Let me take x minus y. So we'll take in difference all the elements of x which are not present in y. So here the difference is A minus B minus C. So it means the element belongs to A minus B but doesn't belong to C. Okay. Now again, by using the same criteria, that is definition of difference, what I can write? X belongs to A minus B. It means those are, what is the definition? The elements of A to be taken which are not present in B. So what does it mean? It means X belongs to A and X doesn't belong to B. And previously we have taken X doesn't belong to C. Now what I have to prove? I have to prove that it is equal to A minus C minus B minus C. It means I need to collect A with C to find that expression. Okay, so when I am saying that x belongs to A, x doesn't belong to B, x doesn't belong to C, it means x is in A but not in B and C. So I can write it like this also. X belongs to A, x doesn't belong to C, X doesn't belong to B. This is just commutativity. What is the commutative property? Commutative property is A and B same as B and A. The AND operator is commutative in nature. So I have just changed the location just to get my right hand side expression. Okay. Now what I am getting? I am getting that X belongs to A, X doesn't belong to C. And the same type of expression I want in difference. The right hand expression I want in difference. So I can simply write X belongs to, what is the scenario? It belongs to A but doesn't belong to C. X belongs to A, doesn't belong to C. It means we have to exclude those elements of A which are in C. We have to exclude A's element which are in C and others we need to take. So what does it mean? X belongs to A minus C. This is what was desired in right hand side. So X belongs to A and C, A minus C, and what else we are having? X belongs to B. Now what else we want? We don't want B. We want B minus C. Now see, X doesn't belong to B. It means no element of B is there. It is not element of B. And what is requirement of our right hand side? We have to take B minus C subset. B minus C set. What is B minus C set? That is subset of B. So when X doesn't belong to B, it will definitely not belong to any subset of B. X belongs to A minus C. When X doesn't belong to B, so it will not also belong to any subset. What is B minus C? B minus C is one subset of B. In B minus C, B's element are taken which are not present in C. Okay, so X belongs to A minus C but doesn't belong to B minus C. What does it mean? It means X belongs to A minus C, doesn't belong to B minus C. It means minus B minus C, which is our right hand side. Okay, what does it mean? It means X belongs to the right hand side. Okay, so what we have shown here, we have taken any element of L and we are able to prove that it is also element of R. So what does it mean? It means all the elements of L are present in R. So it means L is subset of R. So we have taken one element from left hand side. We have shown that it is present on right hand side by taking few property of definitions. And one more thing we took here, that is the commutative property to rearrange these. Okay, so this way we can show that A minus B minus C is equal to A minus C minus B minus C. Same steps can be taken to show that. Similarly, we can prove in using the reverse step that R is subset of L, and from here we can say left hand side is equal to right hand side. So this way we prove the set statements left where expression, two equal expressions are given. So we can use the method of definition, okay, to prove that the two expressions are equal or not. So now let us do one more question here. Now the question is A minus B. A minus B we have already discussed. A minus B means all the elements of A which are not present in B. Same way B minus A will be all the elements of B which are not present in A. So what we have to show, A minus B union B minus A is equal to A union B minus A intersection B. So again let me take it as left hand side and this I take as right hand side. I'm having left hand side, right hand side. I need to prove left hand side is equal to right hand side. So I will use the subset property that if L is subset of R and R is subset of L, then I can say that L is equal to R. So again, I'm using the same concept that we have used in the previous question. Okay, so let us take our left hand side. What is our left hand side? A minus B union B minus A. Okay, so to show, we will use the same criteria, same way of doing. We will take one element of L and we will show that that element is present in R also. So what does it mean? It means if I take any element of L, I will find it in R, so it is subset. Okay, so same thing we are doing here. So I am taking one element from left hand side. Let me say X belongs to L. I have taken one element of L. What does it mean? If X belongs to L, it means X belongs to A minus B union B minus A. A minus B union B minus A. Union means the element is either in first set or in second set or maybe in both. So union contains all the elements from A as well as B. Okay, it is collection of all the elements which are present in A as well as in and B, all the elements. So now what I said, I took an element X that belongs to left hand side. So from here I can simply say that X belongs to, this is union property, union definition. What is definition of union? By definition of union. What is definition of union? The definition of union says that the element is either in first set or in second set or in both. So I am taking or. Okay, so X belongs to A minus B or X belongs to B minus A, because we are having here union. Okay, so X belongs to A minus B or X belongs to B minus A. Now, what does it mean? Either X is in this or is in this or maybe in both. Okay, now if I consider X belongs to A minus B, what does it mean? Now, by definition of symmetry, by definition of difference, this was definition of union and this is definition of difference. Second, so I am writing with definition of difference. What? X belongs to A but X doesn't belong to B. It means and, comma is I am writing here for and. Okay, X belongs to A but X doesn't belong to B. That is my OR operation. X belongs to B minus A. What does it mean? It means X belongs to B but X doesn't belong to A. So from A minus B we are getting X belongs to A, X doesn't belong to B. Okay. From here we are getting X belongs to B and X doesn't belong to A. Now we can use distributive property. AND is distributive over OR and OR is distributive over AND. This we are using here. So here we are having AND and here I am having OR. So I will use both the properties. Okay. So firstly I am applying distributive property on this OR. Okay. So how we will do this? X belongs to A, X doesn't belong to B, or X belongs to B. X belongs to A, X doesn't belong to B, okay, or X belongs to B. And I can write directly and. What is the second? X belongs to A, X doesn't belong to B. I am distributing this OR over this AND. I am distributing OR over AND. Okay. So X belongs to A, X doesn't belong to B, and X doesn't belong to A, right? This is my and let me take it as a O. Same. Now see what is there. X belongs to A and X doesn't belong to B, or X belongs to A, B. Again we can use distributive property. So what we will write here? X belongs to A. I am distributing this or over this, and X belongs to A or X does belong to B. Then and X doesn't belong to B or X belongs to B. Doesn't belong to B or X belongs to B. Again and. Now distributing, sorry, this is OR. We have distributed OR. Okay, right? What is this? X belongs to A, X doesn't belong to, X belongs to A, X doesn't belong to A. What we are distributing? OR. What we have distributed, let us repeat it. What we have distributed OR over this. Okay, so X belongs to A, X doesn't belong to B, or X doesn't belong to A. This is our OR, right? This OR we are distributing here. What we are distributing? X belongs to A or X doesn't belong to A. Now again and X doesn't belong to B or X doesn't belong to A. So we are having four conditions: X belongs to A or X belongs to B, and X doesn't belong to B or X belongs to B, and X belongs to A or X doesn't belong to A, and X doesn't belong to B or X doesn't belong to B or X doesn't belong to A. Now see, when we are talking about these two terms, so what it is saying? It is saying that X doesn't belong to B or X belongs to B. It means we are taking those elements, or means either this or this, or we will take all elements of this or this. What does it mean? Or means all the elements will take from here as well as here. So what are elements of B? That we will take, as well as we will take all the elements which are not present in B. It means this is representing universal set. Same way here, X belongs to A means we will take all elements of X, or means whatever elements are present in this or this, all will be taken. And what it is representing? X doesn't belong to A. It means we are taking other elements also which are not present in A. So X belongs to A or X doesn't belong to A also represent the universal set. So both are representing the universal set. So when we take universal set and operation with any set, then that will be our result, because all the elements are present here. So and means common from here and here. So this can be simply removed from the expression, because it is representing the universal set, and any set is actually a subset of universal set. So when we will take AND of that set and the universal set, that set we will get in answer. Okay, so from here we can simply remove these, because these two terms are representing the universal set. So what we are getting here, X belongs to A or X belongs to B, and these two have been removed. What else is left? X doesn't belong to B or X doesn't belong to A. Now when we are saying X belongs to A or B, it means union. So X belongs to A union B. Okay, and it is saying X doesn't belong to B or X doesn't belong to A. So again or says that either this or both. Okay, so what is X? X is either not present in B or it is not present in A. It means that is not present in intersection. Okay, so X doesn't belong to intersection. Now X belongs to A union B, but X doesn't belong to A intersection B. What does it mean? Difference. By definition of difference, X belongs to A union B minus A intersection B, which is our right hand side. That is what we wanted to prove. So what we have proven? The first part. What is that? From here we can say L is subset of R. And similarly we can prove R is subset of L by taking the reverse steps. So by taking this we can prove that R is subset of L, and then when L is subset of R and R is subset of L, then we can simply say L is equal to R. So this way we can prove our statements given in terms of sets. Okay. Now a problem will take from relations. We are given a relation. Let me take it R as given. Let given relation R. It is on set 1, 2, 3, 4. It means the elements are 1, 2, 3, 4 on which this set is defined. So what we need to check? We need to check, is it reflexive? Okay, so let me write here. What is reflexive property? The reflexive property says that A is related to A for all A belonging to the set. Let me call this as S. What is my S here? S is having 4 elements, 1, 2, 3 and 4. So I am taking A related to A for all A belonging to S. So I need to check, is it a reflexive set? We need to check reflexive, symmetric, antisymmetric and transitive. So first step I am taking, I am talking about reflexive. What reflexive is? I just told. What is reflexive? When A is related to A for all A belonging to S. Now from here we need to check, what are our elements? 1, 2, 3, 4. It means 1 should be related to 1, 2 should be related to 2, 3 should be related to 3, 4 should be related to 4. So now let us check. Do we have 1, 1 here, 2, 2 here, 3, 3 here, 4, 4? It means these 1 is related to 1. It means 1, 1 should be present in our relation. So we need to check 1, 1 belongs to R or not. So now we can say, we can check 1, 1 is not present. It means 1, 1 doesn't belong to R. It means 1 is not related with 1. So it is not reflexive. If by chance we find here 1, 1, then we need to check for 2, 2, 3, 3, 4, 4 pair also. Okay. So as we have not got the first one, so we can directly say it is not reflexive. So it is not reflexive. Okay. Now let us check the second thing. What is second? Symmetric. What we need to check? Symmetric. Now what is symmetric? If A is related to B, then B should be related to A for all AB belonging to the set. If A is related to B, B should be related to A. Now let us check all the relations here and their reverse. So what is first relation? So what I am talking about, I am checking symmetric. Symmetric I am checking. Now see, 1 is related to 3. So it means A is related to B. So when 1 is related to 3, 3 should be related to 1. So I am checking 1, 3 and I am getting 3, 1 here. So it is okay. Okay. Now 1 is related to 4. Now 1 is related to 4. So 4 should be related to 1. That is symmetric nature. So now let us check 4, 1. 4, 1 is not present here. It means it is not, 1 is related to 4, but 4 is not related to 1. 1, 4 belongs to R, but 4, 1 doesn't belong to R. So it is not symmetric. Okay. Now third property. Now we are going to check antisymmetric. So I am taking third property, antisymmetric. Now what is antisymmetric property? Antisymmetric property says that if A is related to B as well as B is related to A, then A should be equal to B for all AB belonging to the set. Okay, if A is related to B and B is related to A, then A should be equal to B. So let us check antisymmetric here. So when we are taking antisymmetric, we can see from here 1 is related to 3 and 3 is related to 1, but 1 is not equal to 3. So it is not antisymmetric. Okay, now the last one, transitive. Transitive property. In transitive property, what is the scenario? If A is related to B, B is related to C, then A should be related to C for all A, B, C belonging to the set. Now if I see this from here, 1 is related to 3, 3 is related to 1, okay, but 1 is not related to 1. Same way, 2 is related to 3, 3 is related to 1, but 2 is not related to 1. So this is not symmetric. So we have checked that the following, the given relation is not reflexive, symmetric, antisymmetric or transitive. So this way we can check the properties of any relation, and based on that properties we define different types of relation. Okay, so in this lecture we have discussed numerical problems on sets and relations. We have checked different properties of relation, that is reflexive, symmetric, antisymmetric and transitive. Thank you. Jai Hind.